This is Knowledge Engineering with Semantic Web Technologies, lecture number 6, Knowledge Engineering. In this part of the lecture, I want to give you a small example about how to write a program and how to access linked data and semantic web resources with a program. So we are doing linked data programming. What we have already done in the other parts of that lecture, we have talked about linked data in general and how the web of data is constituted of these data sets which are published as being linked data. The point now is, if you have a linked data dataset, how do you publish it in the web? So, of course, there are some native ways of publication, like, for example, you might set up a triple store, so a Sparkle endpoint. So there is a huge variety of software that you can use. For example, you can use OpenLink Virtuoso, so this is also the system where DBpedia is stored on, or there is Sesame, Fuseki, and lots of more that you can use here for this kind of native publication. You should keep in mind that all Sparkle endpoints usually are so-called RESTful web interfaces. It means you can access a Sparkle endpoint not only via the browser interface in an interactive way, but you can also access it as a RESTful web service. So you use an HTTP GET request, with which you can formulate your Sparkle query. And then you see, with this RESTful web service, you are able to receive a result, for example, in XML, JSON, or plain text when you do Sparkle selects or Sparkle asks. But you can also get real triple data formatted as RDF XML, N-triples, Turtle, and so on if you use Sparkle describe or Sparkle construct. The way how you want your data to be formatted can be determined in the HTTP accept header. We have already talked about this when we have introduced Sparkle. So here in the accept header, you can, via content negotiation, for example, say you want to have your results delivered in JSON. And then you can use a Sparkle endpoint simply as a RESTful web service. So this is the most easiest way to access this also with the help of a program. You simply make this make use of this RESTful web service. Okay, so this is one way how you can make use of this. There are other ways of linked data publication. Probably you have already heard also about linked data endpoints, which are not necessarily native triple stores. But for example, when we access DBpedia, there is a triple store in which DBpedia resides, but over that triple store is another application which is called Puppy. You see that here. And it's another layer or another application which, of course, itself accesses the triple store but delivers the data via another user interface where you can see these green DBpedia pages, for example, which are then somehow structured, ordered, and presented in the HTML browser. But nevertheless, Puppy also has the possibility that you can directly access linked data via so-called RDF browsers. So if you are interested in that kind of stuff, you have a link here to the Puppy endpoint where you can access this software and can get more information about this way of accessing linked data. And another way, of course, often data is available already in existing databases which are not RDF databases. They might be, for example, relational databases. And for these, of course, there are additional applications. They are called D2R servers that do nothing else but simply they translate relational data into RDF. And this, of course, is possible. We have talked about how you can translate data that comes from a table to an RDF data. And for that, you see here, for example, the architectural sketch of the D2R server of the D2RQ project. So you see here that you have a non-RDF database on which an D2RQ engine is plugged in, and then you have a D2R server which delivers Sparkle, RDF, HTML, dependent on what kind of clients might access there. So it acts in the same way like a triple store, but it's in the end something which is an overlay over a non-RDF database. These are the so-called D2R servers, and many of the data sets in the Linked Data Cloud, for example, are published exactly that way. Okay, if you want to get an overview what Sparkle endpoints are out there, what can I use, what kind of services do they deliver, you can get here information about the Sparkle endpoint status at datahub.io. So I have here, for example, given you the link to exactly this kind of statistic, and there you can see that about right now in November 2015 we have about 1,000 publicly available Sparkle endpoints, and you see here the number, of course, is still somehow growing, but of course it could grow faster. So this is linked data statistics. So let's get back to our original goal. We want to use, of course, the data to create a web-driven, linked data-driven web application. So how does this look usually? So if you try to develop an application, of course, you might consider required components within your application. What you first use usually, so not necessarily, but you should somehow, of course, make a local storage for your RDF data. So you need some kind of a local RDF store. This can be in memory, this can be somewhere on a disk, or this can be another technical system. So your application should consider a local RDF store for caching all the results that you need. So of course it should then be in memory. Okay, then of course, as all programs, you need some programming logic. So this usually is then the controller, and you need a user interface. And the user interface, of course, is not necessarily linked data specific. But linked data specific are the other two components which in the end, they integrate existing linked data. Like for example, here the data integration component, which can either directly access the linked data cloud, as you see here, or it's connected to a so-called semantic indexer, which itself then indexes the resources which are somehow available in the linked data cloud, and in the end delivers the data to this data integrator component within your application. And of course, in the end, probably you also want to write back data that your application somehow has computed. So for this, you also need a data republishing component that is able to write back data to the linked data cloud. So these are the basic building blocks in general of a linked data-driven application. Okay, and if you try to make use of linked data, of course, you can make use of a variety of existing libraries that you see here. And of course, it depends on the kind of programming language you prefer and that you are using. So for example, I have a few here gathered for you. It starts with a JavaScript library for Sparkle that you can use, or for PHP, there is Arc for Sparkle. Then even for C#, there is a .NET RDF that you can use. For Java, there are several libraries that you can use. Either you use Jena, RRQ, or you use Sesame. And what we want to do here in the course, we want to use or make use the most simplest of all. So for example, if you are using Python as a programming language, we will do here an example in Python, you will see how these linked data resources can be accessed. And this is really straightforward. And in the other programming languages, it works in probably the same way. So the principle is always the same. Of course, you have to consider always the peculiarities of the several programming languages that you are really then, the specific programming languages that you are really using here. But of course, we cannot here address all programming languages. Therefore, I have selected the most simplest one, which is here the Sparkle wrapper for Python. But I have provided links, so if you prefer one of the other libraries here, just try it out, write your program, and of course then you can use public available linked data resources for that. Okay, so we want to use the easiest way here. And we choose a suitable library for Python. This is the Sparkle wrapper. So if you click here on Sparkle wrapper at sourceforge.net, you see here comes up the web page with the library, so for the Sparkle endpoint interface to Python, that you can download for free. So you can download it, you put it on your server, you should have a working Python also on your server, and then you can immediately start. Okay, so let's go back to the slides. So now we have to make a decision which kind of linked data we should use. And of course, it's obvious we are using DBpedia just for simplicity. But of course, you could also use any available linked data source that is out there and connect that with your program. So this is also no problem. But we will use here the SPARQL endpoint of DBpedia. OK, so we have chosen the programming language. We have chosen the data source. And now we have to think of a simple example. Okay, and of course, I put some thoughts into that, and I came up with a rather simple thing, which shows you basically how the access to linked data works. And the application should do the following. So we want to build a simple application that looks for today's birthdays of famous people, and we want to have special famous people. Of course, this has to do with science, so therefore we are looking for scientists. So we want to create a list of scientists whose birthday is today, and we want to include some additional information, like, for example, the year of birth, and if available, we also want to include a short description, and maybe even we want to look for a picture of them. So how do we present this in the user interface? So this is supposed someday to be a web implement or a web application. So what we can do is, of course, we can create a simple HTML web page. So we will do this with Python. It's straightforward, rather easy. It's not a web application. It simply creates a file which is HTML that we can locally then, of course, put on our browser and what we can watch. And we use Python, and we use the SPARQL wrapper for that. Okay, so the task is, create an application which displays today's birthdays of famous people like scientists. So, scientists, how do I get to scientists in DBpedia? Here you have to do something like a manual data analysis. So usually the way I start is if I want to display information about scientists and I have no idea how scientists usually are structured, organized, or represented in that data source that I have, I think of an example instance of scientists, and then I look up the scientists to see what information or what data is available for that scientist. So here I did it, for example, for Marie Curie. I can click here on the web page of DBpedia. So now the Marie Curie page is loaded. So now the question is, we all know Marie Curie is a scientist. So we have to find out which information from DBpedia we can choose to find out that Marie Curie is a scientist. We could look for RDF type. For example, you see it here, RDF type. Now the question is, do we find a scientist? And we are lucky, we see here Marie Curie is among the scientists. It's also a DBpedia ontology criteria. So we have here DBO scientist. And now we assume, because I know it, but you can look it up, most scientists are somehow labeled as being a scientist. And we can use, of course, exactly that one to distinguish scientists from DBpedia, and we can do this on our SPARQL endpoint. So now we have to look what can we display. Of course, we want somehow to display the name. So of course we could use the RDFS label for that. So you see here you have the label Marie Curie. We can display that. We can use RDFS label. Okay, that's nice. What else? Short kind of description. You could use this here right above. You have here RDFS comment. That's a bit long probably. Maybe there is a shorter description. The interesting thing is if you are looking for description, you will find here either a raw property, which is DBP short description, physicist and chemist, but you find also DC description, which comes from the Dublin Core vocabulary. So this is much more sophisticated. You should always, instead of DBpedia raw properties, use either DBpedia ontology properties, because they are verified, they are handcrafted, because we know the semantics of that. These raw properties are simply mapped from the info box without knowing what they really mean. And for DC description, of course, somebody knows that this really means description, and here is the right thing. So here, Marie Curie is characterized as being a physicist and chemist, and of course we can use that. So how do we get a picture? Probably there is some property, but we do not know the name of that picture. So what you could do, for example, the picture, if it's there, it should be encoded, of course, in some file format, like, for example, in JPEG. And here you can look for JPEG. So here we have, for example, a fauve depiction, which gives you a picture of Marie Curie. We could make a click on that and see what happens. So you see, yeah, that's a huge picture of Marie Curie. That's nice. We want a smaller one. So let's see, are there more JPEGs? Yeah, you see here is another one. And we have DBO thumbnail. That's also rather nice. And again, it's the same, but it's smaller. So it's here with width 300 pixels. So we can use something like that. So we should use the thumbnail. So now we have the basics found in our data that we want to use for a Sparkle query to get the list of all the relevant scientists that we want to display. And then, of course, when we have figured out the Sparkle query that we really want to perform, we can put this Sparkle query then in an application. So this would be then the next step that we have to follow. Okay, so this one we have. So we did this manual data analysis. The next thing that we have to do is we have to come up with an according Sparkle query. So next point, Sparkle query. Here we can look to the DBpedia endpoint that we have here. So here is the DBpedia endpoint. Okay, let's make this a full image so it's a bit larger. Okay, so here you see now the entire ready Sparkle query. So of course I have prepared it for you. It starts again with a lot of prefixes. So we need the RDF prefix, the DBO prefix for the ontologies, RDFS, and the Dublin Core prefix for the description. What do we select? So I show it here briefly for you. We select the birth date. So of course the date of birth that we need. We need the thumbnail. Then of course the URL of the scientist we consider. It will be scientist here. Then the name. So this is the string. Then we have a description. And then comes the where clause. So first thing I want to do, that one, is I want to select all the scientists from DBpedia. So I say scientist should be of type DBO scientist. That's the first thing. Then we have all scientists. Next thing I want to do is, of course, I also want to select the birth dates of exactly these scientists. So that's the second point. And I also want to include all the labels, and I also want to include all the necessary descriptions. But, of course, and now things will be filtered. We know, for example, that names and any string that is here might occur in DBpedia in several languages. Therefore, of course, we have to restrict it all to English language, for example. So here I say, okay, I make a restriction on the language of the name should be in English, the language of the description should be in English. So these are the two things I want to restrict here. Next thing I want to find out is a bit more complicated. Of course, I do not want to have all the scientists with all the birth dates. We said in the beginning we only want to have the scientists that have birth date today. And for this, what I do is, of course, I select the birth date, but I have to look whether month and day in the birth date really confirms or is the same like today, the day and the month, to find out whether these people have birthday today or not. So for this, I have to do several things. So usually it's a process. You try it out, you see it doesn't work, and then you try again and you refine. And here you see already the result of my refinement. So what I found out is that birth date not necessarily always contains the day and the month. So for example, for several people, only, let's say, the year of birth is known and not the exact day. Then therefore, birth date is only a short expression which consists simply of the year. So what I have to do here, if I want to do string processing and I simply want to extract here the date, which means I want to extract the month and the day, I simply transform the birth date into a string and say, okay, the resulting string should be larger than 6, which means it should contain definitely months and days. So because the year usually is 4 digits, and then if it's longer, if it has 6 digits, then I know definitely it has a month, and if it's even longer, then I know there are also some days. So, and I do exactly this for the birth date. So I ask whether the birth date is longer than 6 characters. And what I do then is I strip the birth date completely. Here I look at a substring here, and I simply look whether here the first 6 digits or these 6 digits of the birth date somehow confirm to these 6 digits from the current date. And here I use another function. This is called BIF car date. This is a SPARQL or here Virtuoso built-in function that you can use. You can use it here in the DBpedia endpoint. And what it really does here is considers simply the current date. And the current date, of course, is formatted as year, and then comes month, and then comes the day, and stuff like that. So this is, I don't consider 6 digits, so the point is I consider it from the digit number 6. Sorry, this was a mistake. So first you have the year, it's 4 digits long or 4 characters long. Then you have a dash, and then number 6 is where we look at, and this is then the month. And then it's 6, 7, 8, 9, 10. So this is then the month and the day we are looking at. So therefore, this is the start of the substring. Here 6 and here also 6. So this is the correct interpretation here. Keep that in mind. So here I'm comparing these substrings, day and month. Of course, you could solve the same problem in a complete different way. You could extract days and you could extract month with the according functions that might be available in your SPARQL endpoint, and then simply you have to do much easier equivalences and comparisons here. So this is possible. So this is only one of the many possible ways how I get all the scientists that have birthday today. And the other thing is we also wanted to have some images of these scientists. The point is here, unfortunately, not all of the scientists, as I found out, have really pictures associated with them. So therefore, I have added this in the last line as an optional statement. So in the last line as an optional statement, I also want to have the thumbnails of the scientists whenever they are available. Okay. And then in the end, I order my result by birth date, which means it starts with the oldest birthday and it will end with the youngest birthday. And then, of course, I can run the query. And you see here the results. So first I have the birth dates. As I told you, they start with the year, then comes the dash, and then here comes the month. And as you see here, this lecture has been recorded on November 13th. So therefore, these are all birthdays for November 13, and they, of course, here are in increasing order until 1964. Then you have here thumbnails for the people, and you see not all of the people really have a thumbnail, but several of them. Then you have here the URL that we are talking about. You have the name given in English, and also you have the description given in English. So this will be the data that will be included in our application. So this SPARQL query has to be part of our application. So what we will do here is we will include this into our application. Okay, so of course I have already prepared the Python program for you, and now I will show you in an editor my Python program that I did. So this is the Python program. Let's have a look on that. And what you see here, I'm using, of course, several libraries. So one for the interpretation of URLs, one for the interpretation of time and date expressions. And here, of course, I use my SPARQL wrapper that I have previously, of course, installed on my machine. And here I'm using, or you can say what kind of things you want to import. And of course, I want to import the SPARQL wrapper and then the interpretation as SPARQL, as XML, N3, and also RDF, for example. Okay, the next thing I have to do here is I have to say which SPARQL endpoint to access. So here I have a variable which I call SPARQL, and I assign here, I call the SPARQL wrapper with the address of the SPARQL endpoint I want to address, and this then is dbpedia.org/SPARQL. So this is the access point, and then comes the SPARQL query. So the variable SPARQL here has one method, or the object Sparkle has one method here, and this is called setQuery. I can do setQuery here, so that's a method here, setQuery. And here I can directly copy my entire Sparkle query, like I had it in my Sparkle endpoint. So that's exactly the same. You only have to take care, though this is a peculiarity of Python. So of course the query might contain, for example, quotation marks. So therefore you have to put it in Python in 3, just keep it in mind, 3 quotation marks. That these quotation marks inside here then are not interpreted as Sparkle commands, as Python commands, but they belong to Sparkle then. So you see here everything inside the parameters of that method is within 3 quotation marks. So this is here a mandatory thing to do. Okay, so this is my query. After my query, so you could also include in this query, for example, local variables. So if you want to introduce local variables to fix some values, for example, it's no problem. You can simply include them here. And of course, you have to take care that in your query, then your local variable will also be included with the value that the local variable here then carries. So it has to be excluded then again from these quotation marks, but we don't did it in this small example here. So this is also the easiest way to do it. Okay, so we have the query. Next thing we have here, we set the return format. So another method, we say the return format should be JSON. And then, of course, we carry out the Sparkle query. So that is that one. So here we carry out the query and convert it in exactly this JSON format. And then we have it here. We have something like a hash map, and there are all the results. And then, of course, next stuff that comes is only Python. We have to read what is in these results that are returned from the Sparkle endpoint. You see here, the Sparkle part really is quite easy. You say what is the access point, what is the query, in which kind of data structure the query will be copied or processed. That's it. Okay, so now comes Python. What I do here is I create an HTML output, which means I create here an HTML page with the according markup text, HTML text. I have a header which I call Scientific Birthdays of Today. And then what I do, for example, is to put on the website that I want to create on the HTML site also the current date. I need this date time library that I have included up here, and from this I take then here what I need. So it's the date today that I take from here, and this I put here simply in the first line in the header. I say scientific birthdays of, and here this is a placeholder for the value of the first variable that will be included here, and this will be here the date that I include here that has been produced here by that library. Okay, then I start an unordered list, so with the markup tag UL. And now here in the unordered list, as single list items, I want to include the results from my Sparkle query. So what I do here, I start a loop around the result data structure. And here the results are ordered like I have a key, which is results. And then I have the according value, which is in bindings. And I say if the key is scientist, then I take the according value, which is associated to scientist, and I create here a URL because this is interesting. I want to create a website where I can look up exactly that character, that person, but not in DBpedia, but in Wikipedia. So I get Wikipedia information. So the first part of this URL here is Wikipedia. And of course, I simply add the URL from the scientist, but I take only the final part after the last slash I have in here. So this then will be together the URL that is used here. So if there is no scientist, then I simply write nothing in this URL. So I write none in it. Then I do the same with the name. So I add here the name value. I encode it here in ASCII. And then I read the birth date. Also the birth date here will be encoded in ASCII because I simply only write it. Then the same with the description, and then the same with the thumbnail. With a thumbnail, that's also interesting. So if there is no thumbnail, then I use a standard placeholder for that, which is an image GIF image of a question mark, so that you see, okay, here is something missing. And this is in Wikimedia already available. Okay, so next thing, what I want to do. So the next thing I do is I do some date processing. Where do I need the date? I need it here. So what I simply want to do, I have the string again that I have read here. And so the date that I have read here, and I want to interpret it the following way, that the first part is here written as years, then comes months, and then comes day. And I want here to include the year on the first place in my ordered list that I create here. So I want to have the year, and then the next thing I want to have here is the picture. So I include here after the year. This is the first placeholder for the year. Then I include the picture with an image tag, and here in the source there must be the URL of the picture. And in this URL, so this is a peculiarity, I replace somehow the expression 300px, which is a directive that somehow says to the server where the image or this specific image is delivered that it should be of width 300 pixels, it should be smaller, only 60 pixels. So this is only for adapting somehow the output format. You don't have to worry about that. Then, of course, I include here the URL. So this is the Wikipedia URL that comes then here. So this is linked, as you see, it's in an href. So it's in, this is here, you see it's in here. Here comes the URL, here comes the name. This is in an anchor tag. And then I have here the description. This is the last thing. And then, of course, if I have all of them, so we will go through all the results in the list. So we process all the rows. Then I will close the unordered list, and then the document will be finished. So this is my Python program. Okay, so now let's try out the Python program. So for this I have to go into a command shell. So this is a command shell, and I have to look whether I'm in the right directory. I am. So I do this directly in the SPARQL wrapper library. It has a subdirectory which is called scripts, and there usually are some examples that show you how the SPARQL wrapper really works. And the example we have here is example 02. This is our example, and this can run if we simply say, let's put it here where Python, and then I say, okay, the name of the Python program is example 02. And I run this, and you see the result here is, as you see, some kind of an HTML file. So what we will do, we will put this into another file which is called scientists.html. Now let's have a look how this scientists.html will look in the browser. So for this I have to switch to the file manager, and here I have scientist.html, and I will put it in the browser. So you see here now the result in the browser, and these are the scientific birthdays of Friday, November 13th. And you see here it starts 1715 with Dorothea Erxleben, physician, who, by the way, was the first woman who received a doctorate in Germany. And you see there are lots of people who have birthday today, and for some we have a picture, as you see here, and for others we don't have a picture, and there only this picture with a question mark then is presented. So this would be the result, and for example, if you are interested in that, you simply click on that, and then you will be on the Wikipedia page, the according Wikipedia page. So this is quite nice, you see here, and you can create this, of course, with the little program you see, and for every day it will create a new table of scientists which have birthday then on just that day. Okay, so let's go back to our presentation. So what I've shown you so far is how you create a Python program that somehow deploys and applies semantic web linked data structures, and how to make use of them. So this is quite easy, and this is again the result of the program that I've shown you. So if you prefer another kind of programming language, basically the principle how it works, it's always the same. So here you have the example for Java. You have to import the according library, which is then accessing RDF data or SPARQL data. So here, for example, you import Jenna and the RRQ library, which also, so in Jenna you are also able to, with RRQ you can do SPARQL queries. And then you have to provide here in service, you have to provide the address of the SPARQL endpoint, and then here you have a query where you have to formulate your entire query. And then you start your execution. So here the commands differ from library to library. So what you do here is you set up an execution factory, and here you have a SPARQL service, which you give them your service variable here where the endpoint is and the query where the entire query resides. And then you execute here. This execution factory produces here a query execution, and here in the query execution you can execute the query. And this in the end gives the result set, and then you have to step through that result set. And you do it, of course, according to the peculiarities of the programming language that you use. And here is the example how you would do it, for example, in Jenna with Java. So this is the Java example. And basically also in the other available libraries and programming languages, it works about the same. Okay, so this was a short example or a brief example how you do linked data programming. So in the end, following that principle, you can build applications that make use of this huge amount of data that is out there in the web of data with a standard single interface. That's the nice thing about it. So you simply use that HTTP-based interface to SPARQL endpoints. You are using this RESTful web service, which is quite nice and which is available at all the SPARQL endpoints. And you can make something. You can build mashups out of that data. And this, of course, might be a nice thing. Okay, to further work on applications that we have in mind for knowledge engineering, in the next part of the lecture we will talk about metadata and semantic annotation, which is essential if you want to open up existing documents for the semantic web.